It's another Toolbox Tech Talk this Sunday, and as they've started to evolve, we're starting to bring in more guests via pre-records, and this is another one. The guest today is really an old industry friend, Paul Wilson from RVO Australia. And Paul and I share a lot of different things. We've both been involved in batteries and solar for a long time, but also some of our lifestyle choices. So you might notice the top here. We're both vegans, actually, and we even get onto that at the end of the podcast. But mostly it's about lithium titanate, battery storage opportunities that are going forward. So anyway, over to you, Paul, and thanks for coming along to my studio.
Cool. Look, thanks for coming. Up top of the mountain on a less than perfect day.
I love coming up here.
It was a much nicer day this morning. I woke up because we've had like rain for, I don't know, a week, not like quite 5 days, and all the batteries are low and everyone's EV's empty, and there's just like, the first thing this morning when the sun came up, I got all these messages from the EV owners here saying, can we come and charge? Can we come and charge?
They should just drive down the hill. They'll charge their batteries, won't they?
Yeah. Actually, you get about 1 or 2% extra charge by the time you get to Healesville than when you started.
All right, there you go.
Yeah. As long as you don't ever come home,
and
you're good.
If you're plugged in down there and exported, you'd be like a off-grid export. Yeah. All right, a bit introduced. So, Paul, we've known each other for, over 10 years, I reckon. Yep. I still remember you did one of my early Grid Connect, standalone power system courses. I did. Yes. at I think Swinburne TAFE, I think it was.
Yep, at Wanturna. Yep. Yeah. Gosh, bit of water under the bridge since then.
A lot of knowledge since then. Yeah.
Was that kind of a turning point? You were moving into off-grid then? Was that kind of why you did the course?
Yeah, I was interested in batteries because I knew that'd be the future. They had to come and they had to work properly. So, yeah, I thought time to learn about it now. I had some time on my hands.
Right. Oh, cool. So it was a course in those days that was mostly full of electricians doing the course, but there was still the opportunity for people who were from a design perspective to do it. I guess that's where you sort of latched in. Yeah,
that's right. I think they stopped letting us do it after a while. I think they banned the non-electricians from becoming trained, which is a bit odd, but that's what happened. Yeah,
it's a very sad kind of transition. There's no kind of like reason it can't be done. It's just that the TAFEs have chosen that it's a one-way path now for them. And maybe the economics don't work for them. I don't know, but I used to run the course over 2 years. It was like a major course, and it was very few electricians would be on it. It was mostly people interested in renewable energy.
Yeah, I remember doing the course and I had to do recognition of prior learning. So that's when my mechanical engineering from uni came into play. So they took me aside and said, we don't mind you doing the course, but you need to prove that you at least know these things first. So it wasn't that easy to get in.
You had to show which end of the screwdriver to use?
No, I think I had to explain, V by I,
Oh, okay.
So they asked some difficult questions.
Oh, cool. So how do you think the world has changed since then in the renewables area?
Well, obviously there's a huge influx of grid-connected PV now, and the cost of PV's come down a lot, and it's obviously skewed even lower with our STC program here in Australia. So I think there's a lot more PV to go in, but also then to transition away from fossil fuels in a heavier way, we need to obviously get the battery part right, and that's why I started getting involved in designing batteries several years ago, because I just wanted to make sure we did it properly and had a safe solution for people.
Yeah, it's really all about batteries at the moment. It's amazing, and I think the recent announcement by the AEMC might stimulate that a bit more.
Yes, that's right. No, it's good to have people, lots of different bodies getting involved.
Yeah. I mean, for those who are not familiar with the Australian energy market, what's the C stand for? Commission, who kind of involved in setting or doing some of the background for the rules for the electricity market, have recently recommended that there's a two-way tariffs. So if you export energy, you actually pay to export.
Right. Well, that kind of goes against the whole grid thing, doesn't it? The rules are that with AEMO that if you produce energy, you don't pay for use of the grid. It's only the consumer. So that's a big turning point.
I must admit I'm not fully across it yet, so apologies if I haven't quite got the pitch right. But yeah, there's general horror from solar customers and probably solar installers too, that just pure grid connect is going to be a very tough sell.
Yeah, okay. That's where batteries come in.
Totally. Yeah, batteries come in. I mean, you've been involved in energy storage for a long time, but is it sort of changing now? Is it the economics of it?
Yeah, well, I think the key to making batteries work is there's a few parts to it, obviously. Obviously, first one for us was safety, and we made a decision to use the LTO type cell for our battery technology because of it had one of the highest safety standards compared to other types. That was a big thing for us. And then longevity. The longevity tick box means you can actually get a payback and then you get more life as well. Whereas a lot of other technologies get a payback and then you have to replace them. So it's kind of not really that good a story. So I think safety, longevity is a big one. And also I think the longevity then feeds into recyclability as well because, I think the old story about the nickel metal hydride batteries, they said they'll be recyclable one day when they invented them. And there still isn't a recycling plant. I've heard that, I don't know if it's true or not. And I worry also that, there's a lot of lithium-ion batteries come onto the market and they're not built well and they last a short time. What are we going to do with them all? It's a big problem. So I think battery design that lasts a very, very long time reduces that risk as much as possible.
Yeah. That story, I'm probably referring to nickel cadmium, but probably nickel metal hydride as well. But nickel cadmium, really toxic stuff, cadmium in the environment. 30, 40 years ago when they first hit the market, it was, don't you worry, we'll have a recycling program for this in no time soon. Yeah. Well, there's no cost benefit in having a recycling program for a really difficult to dispose of material. Yeah. And so 40 years later, they just get dumped.
Yep.
Yeah.
No, it's not good.
Yeah.
And also then there's a lithium-ion battery recyclability difficulty. There was, I think, a fire in a lithium-ion battery recycling storage facility in Melbourne maybe a few months back, 6 months back, and it burned the facility to the ground. So, but let's try and make batteries that last a really long time so that in 25 years' time, then we can deal with recycling with much less batteries. That's how I look at it.
Hey, I've got a prop for you. Look over to your right.
Oh, yeah.
Do you know what that is?
It looks very much like one of our cells.
Yeah, I think the label's worn off or never was on there, but yes. So tell us about what is that cell you're holding there?
This is an LTO cell, and it's made of lithium titanate oxide, and the lithium titanate oxide is produced in tiny spheres, which gives it enormous surface area. So it sort of behaves a bit like a capacitor because the surface area allows electrons to flow in and out very fast. And this particular cell here can charge in 6 minutes.
Oh my God! Right.
So
okay.
That's 10C.
Yep.
But it can also handle bursts of 20C for 10 seconds. And we've been testing this actually. We thought, it's great to have a manufacturer tell us about the specification, but it's even better to test it. So we put a pack together with 24 cells and started cycling it and thought, well, how fast can we cycle it? Well, there is an internal resistance of this cell of, I think it's 0.3 milliohms. Now, it doesn't sound like very much, but if you put 2 kilowatts through 24 of these cells every hour and then you empty it every hour, it does get a little bit warm. So we found that the battery charged at the 1C rate over 1 hour produced enough heat to bring the battery temperature up to about 42 degrees from 25 degrees. And so I thought that was acceptable because the cell technology is safe between negative 50 and plus 60. So we thought, well, if it's okay to run to 42 degrees regularly, the manufacturer said that the cell should be able to do about 4,000 to 6,000 cycles if we keep it at 55 degrees Celsius, which is very hot. So we thought it should do a lot more than that at 45 degrees. So hence the test. So we started testing it in July last year, and we started cycling it every hour, 12 times per day. We set up a Cellectronic SP Pro inverter using the Emax, which is the little black box on the screen there.
Ah, yes. Yep.
So the Emax lets us control the SP Pro and gather data from it and go in through SP Link remotely and so on. But the big key was that we could actually tell the Emax to tell the SP Pro to charge the pack hold it for a minute, and then discharge the pack until it reached, say, 46 volts, I think it was, and then stop discharging, then turn around and charge again. So we had this sawtooth function. And we can log onto it later and I'll show you that working. So it's been running now for 8 months at this rate, 12 times per day. United Energy turned up at the meter with the test equipment because they couldn't work out why their meter was sawtoothing. The guy was out there, he had a hairdryer and he had all this equipment and he's going, I don't know what's wrong with this meter. It's got this like jagged pattern and it keeps filling it export import. So we're using the grid to export the 2 kilowatts all night long, all day long, 24 hours a day. So that was pretty funny. Explained it to him and he said, thanks for that. I can go home.
I'm impressed they even monitor that.
Yeah, I don't know. He just had a report that this meter was reporting this export at night, every hour, and then import again. So, like, they couldn't obviously detect the import, but the export was unusual. So they must have detected it because they came out. Anyway, so it's been cycling like that, and we've been plotting the history of degradation to see really how long will the cell last properly in a real world. I mean, that's not a real world test because nobody charges their battery 12 times per day at 45 degrees Celsius. So in any case, we've found that over 8 months, that simulates 8 years at 12 cycles per day. We've lost about maybe 5 to 10% of the capacity of the cell over that period at that high rate, which says to me that at a lower rate, with lower temperatures, we'll get much, much more. And the projection from the manufacturer is 25,000 cycles to 35,000 cycles at 25 degrees Celsius, which is up to 80 years at 1 cycle per day.
Wow.
So it's a big difference to a lot of lithium-ion technologies that are out there.
Hey, just coming back to the cycling 12 times per day, I can think of an application for that. So for commercial and industrial customers who are on from the 1st of October this year will be hit with the 5-minute settlement for maximum demand, which means within a 5-minute period, if you shoot your peak, you pay the penalty for the rest of the month.
For the month, okay, so it's not the year at least.
Yeah, not the year, the month. So that means you really, if you can absorb 5 minutes of peak,
great point,
and then recharge again.
Well, you can. So the SP Pro can do it. So because the battery can charge so fast, that's a high C rating, we don't need much energy storage to get the power we need. So if we took a 1202 SP Pro, which can peak at 40 kilowatts, on grid it can peak at 24, I think it is, when it's grid coupled. Then you can do 24 kilowatts per phase by 3. There's 72 kilowatts, or is it 72 kilowatts? Yeah, 72 kilowatts across 3 phases. And we could support that with only, say, 1 battery made up of 60 cells because we've got so much peak power. So
right.
you don't need to buy a ton of kilowatt hours to get enough safety to charge fast. You can actually have quite a small battery. So you could actually get away with a 6 kilowatt hour battery running at 10C, which is producing 60 kilowatts of power.
So really the lithium titanate cells are great for that peaky load, but can they do long, slow discharge? Are they suitable for off-grid as well?
Oh, absolutely. We've got a lot of off-grid projects running now. Hospitals, nursing homes. We're about to do a coal power station. It's ironic.
It's so ironic, yeah.
And everybody's concerned about the longevity because, the further you go away from your base, the more expensive it is to recycle a battery. And the more of a problem is if it fails, because you can't just order a battery and have it delivered tomorrow. So having very long life batteries is a very big plus for an off-grid system.
Yeah. Oh, you've got 20 years before you need to recycle it, and recycling a lithium titanate, what's involved in that?
Well, because there's so few cells, I think recycling should be much easier. Now, we haven't tried to pull one apart yet, but they're rolled. I think I'm not sure how long the roll is of foil that holds the cell together, but if you slit it on the side here, you can open it up, the whole cell. Whereas if you had the little cells, what are they called? The
18650s.
18650s, or the other ones, the 20 whatevers.
Yep.
And you've got 2,000 of them, that's not very practical. Whereas here, you've only got to slice the side and open it up. Now, that doesn't mean I know how to recycle it, but I think it would be much easier than lots of little cells. And also, the whole battery we build is built with solid aluminium bus bars, which have a value, stainless steel bolts, very high thickness copper. So there's a lot of raw metals in the battery that makes it attractive to recycle and makes it worth the trouble.
Yeah, I can see that with the size. You're right. It's human friendly for recycling, and there are some chunky materials there. What's the main material? The weight of it. What's that really made up of?
Probably the carbon is a big part of it, and then there's the lithium titanate oxide, which may be 20% depending on the actual generation of the cell, and there's aluminium and copper. So,
like you say, all valuable minerals.
They're worthwhile recycling. The only thing is just the electrolyte. Really, is the safety of the electrolyte. You've got to deal with that. The good thing is they're very safe cells. Like, I've got a video of it. You might have seen it where the manufacturer cuts it with a saw, almost to the center, and the cell still operates. There's no fire. There's no thermal runaway. They puncture it with a nail in underwater, and it doesn't do it. It doesn't catch fire. It doesn't stop working. It actually keeps working with a hole in it. So that's probably got some good military applications. Bullet goes through the battery, and the battery still works. Whereas if you do that with another lithium, some other lithium-ion brands, they're not safe like that. So that's why I like this cell, because it just means you can use it in more places. The downside is it costs more money. Upside is it lasts longer. Downside is it's not as energy dense as other lithium-ion batteries. So for cars, it's probably not a great choice if you want long range. But if you want short range and often recharging, like a Mitsubishi PHEV, for example, where you don't need long range, you just need high peak power, this is a great option.
Yeah. Where will we find one of those vehicles?
Mine's parked outside. I actually jumped, and funnily enough, this is a long story if you don't mind.
Go for it.
So I jumped online the other day. I was thinking I should upgrade my battery in my PHEV. It's done 150,000 Ks now. It's getting a bit old. The range was being reduced. I jumped online and Googled it, as you do, and find out what everyone else is saying. And they're saying, these Mitsubishi batteries don't last as long as they should, because they're doing a lot of work, which I can understand. People are complaining, blaming Mitsubishi for it. And I think, the real thing is you just need to replace the battery. So I looked up what was the range of this battery. And people are saying it can do 1,000 charges. That's not many.
No.
But that's the rate of it. So that's what Mitsubishi's PHEV battery does, 1,000 charges, according to people who are investigating the cells, because Mitsubishi won't disclose it, but that seems consistent with what's happening in the market. Whereas the lithium titanate oxide is 25,000 cycles. So I thought, okay, I'll take our 6 kilowatt hour battery that we built for the shipping container and see if it fits in the back of my car. Well, and it did. 2 of them side by side fitted perfectly between the wheel arches, like with 40 mil to spare each side, 200 kilograms, 13 kilowatt hours of extra storage, and the voltage of 2 batteries series connected is exactly the voltage you need to parallel with the Mitsubishi battery. Exactly.
It's in there now?
No, it's up my next project.
Next project.
So I've designed it all up. So I jumped online. I thought I just spat out this story that I had this idea. I want to put my batteries in my car, and I wanted to have people's opinion, because maybe someone's got some wisdom out there that And people came back with all these great ideas. This guy comes back, I've hacked into the CAN bus and I've got all the CAN bus protocols, so I can tell you how to get into the CAN bus data between the engines and the battery and intercept it and repeat on the data, but change some values so that the car knows the changes. And he goes, I did it with my motors. I changed it so that I could get more power out of the front motors and the back motors in a better balance. And the car drives much better once I started hacking my own car. And so he gave me all the protocol codes. So it was worthwhile posting, So now I've got to build one of these things.
Hey, I've got a customer for you straight away. My electrician's just bought one of these, but she's bought quite an old one. I think it's, 8 years old or something.
Right. Well, mine's one of the first ones in the country, so it's probably the same 2014 series.
Something like that. That's right. That'll be hers.
Yeah.
She'd be pretty interested in that. She was actually talking about, are there kits available to add more storage? So
no, there aren't, but this is what we're going to try. So
okay.
Yeah. So why not, I say? And that'll, because these batteries can peak at such a high peak rate, these 2 6 kilowatt hour packs in series will give me about 120 kilowatts of peak power. And the car only has 60 kilowatts worth of electric motors. And the existing battery can already deal with it. So when we parallel it, we'll have, probably 200 kilowatts of peak power available for these 60 kilowatts worth of electric motors. So there's plenty of peak power.
Yeah, I mean, it's really unfair when you ever compare an internal combustion engine with an EV or a hybrid. Just the power of a DC motor is awesome for its size.
The torque, yeah.
Yeah, the torque is amazing. Like, we've got a Kona EV, and I think it's 150 kilowatt motor in that, and it's a little car. It's basically a go-kart.
Tear the tyres off, wouldn't it?
Yeah, literally, you spin the wheels at any speed if you put your foot down hard enough. It's just got an enormous torque.
Yeah, that's great. No, I love it. I love doing that. And I think also that, the Mitsubishi PHEVs are an incredibly well-built car. Like, when I first drove it, I thought, how on earth did they get this thing so right the first time? I just couldn't believe it. You go, oh, first car in the series, it's going to have problems. This thing drove like nothing. You couldn't believe it. And so recently it started to develop this clunk. So when I accelerated it would go clunk. I thought, oh, maybe something's wrong with the diff, but how could the diff get damaged? It's a Mitsubishi. It must be beautiful. Took it to the service department at Mitsubishi after putting up with this clunk for about 50,000 Ks, as you do. And the guy goes, oh, you've just got a bush that's split in the back diff suspension system. It happens a lot in these cars because they've got so much torque. So when you accelerate, the car twists like this.
Ah, yeah, right.
Guess what? $350 later, they changed over the bush. And the car's like brand new again.
Yep.
No clunk, it's smooth as anything. I thought, this is the first car I've had in probably 25 years that I've kept beyond one set of tyres. I'm to my third set now. Every time I got to 2 or 3 years old, I thought, it's a company car, I'll just trade it in. I won't spend any money on it. I'll get a good price for it now. That was my mindset. This thing got to 3 years and I'm going, I'm not giving it back. It's too nice. And it got to 5 years, I'm not giving it back. Now it's at 7 years, I'm thinking about putting more batteries in it. So.
Wow. I mean, that's just great for the environmental benefits of not turning over the vehicles too much.
Definitely is, yeah. So they drive better and they're smoother and they're nicer, more pleasurable to drive than a standard petrol car by far. So.
Hey, I've discovered a new thing I'd never really thought about with an electric vehicle is that it's powered by electricity, obviously, even when you're not using it. And so, I mean, our Kona's got a SIM in it and you've got an app and you can tell it to warm the car up in the mornings. Yes. So on a cold winter's morning, you just turn the heating on, get the car to the right temperature, and so you step into a lovely warm car.
That would be good up here too. What's it get you up here in the winter?
Down to zero. Yeah, down to zero.
Yeah. Well, that's probably where these cells would be good for you, I think, because they're rated to -50. I've been told, though, someone did some testing on them and they said that they had troubles at -20 getting them to work really well. So I'm going to do some more testing now at really low temps and see at what threshold point you actually lose your peaking limits. But I think the way to solve that is you just short it out a little bit and it'll get a bit warm.
Yeah. I mean, thermal management of a battery pack is used by quite a lot of the EV manufacturers to get the ability to charge at like -20.
Right.
Because most lithiums don't like being charged at really cold temperatures.
Yeah.
You have to reduce the charge rate. So you might as well use some of the energy that you've got available from the grid if you're plugged in, or even with the vehicle, just to warm the cells up a little bit using their internal resistance, or run the aircon.
Yeah. So the BMS we had to develop to manage the cells was we used a supercapacitor-based balancer, which basically fills up from the highest cell and exports into the lower cell. It just basically is like bailing water out of a boat. And that works really well. It's very efficient. There's not very much loss because the supercapacitor that fills up off this cell is extremely efficient. And we're only paying for the toll of the FETs that are doing the channeling. Right. So that works well. And then we had to hook that up to a monitoring platform to look at the cells across the whole system to decide if any cell was not being balanced quickly enough, because LTO cells, they run away in voltage very quickly, because they've got almost no internal resistance and the energy has to go somewhere. So once you get them full, they hit here and then they just go like this. So we detect that quickly and we tell the inverter to shut down or to back off until the balancers can catch up if it gets right to being almost full. And then we look at extra safety measures if something doesn't happen. Let's say the installer forgot to connect the stop on the inverter and the battery then gets full and the cell gets high, then the next step is strip the battery off the battery bus. So they've got a built-in motorised circuit breaker with a shunt trip in it.
Right.
So the final mile.
You've got lots of levels of protection then. So through communications, through overcurrent protection built in, and through self-tripping.
Yep. Just because we just don't know what will happen. Someone might make an honest mistake or program the inverter wrong, or an inverter might get an upgrade from the manufacturer that might reset the settings, and you know, there's a lot of things that can go wrong in 20 years.
That's something that, so-called dumb batteries don't have, which is if you set the settings wrong, you wreck it.
Yeah. So these funny you should say that, because our cycling battery that I've got running, we recently took the balancing board out to test on some other piece of equipment, and one of the techs who put it back into into the battery, forgot to turn it to 24 cell mode and put it to 23 cell mode, because you can set it in the software, in the app. It's got Bluetooth on board the device. And so this battery was balancing with only 23 cells, and the 24th cell wasn't balancing for a month. So I thought, oh no. And I looked at the capacity, it was diminishing a little bit, because this one cell was filling up to 4 volts, and it shouldn't be. It's only limited to 2.9 volts normally. I thought, oh no, I've wrecked it. So got back in, turned that cell back on again, got into the app, turned it on, checked it, and after 6 cycles it had pulled back down to the right range as every other cell, and it's back on track again. So even though it failed, it was a really good test for fail, to know that even a cell at 4 volts actually isn't dangerous. There's no, the cell wasn't hot, it just didn't like it.
Right. Hey, thinking of thermal management, maybe also your beer's getting warm.
Yes. That one. Is it made of plums as well?
No, it's not. It's not the home brew that you had before.
This is Glenn's homebrew plum vodka. Highly recommended.
Actually, my neighbour made that one, but I also make some of my own hand sanitizer. Hand sanitizer.
Oh, sorry, yeah, of course, yes.
You're drinking hand sanitizer.
Spill in your mouth sometimes.
That's right. It can get dangerous drinking it, but there you go. So much to talk about. So, look, thinking of these batteries that you've produced, we've talked about them being used because they're safe and the recyclability, and that they can be used off-grid and on-grid. What about scalability? Are they suitable for small systems, medium, big?
Well, definitely good for very small systems, because they've got so much peak power. Quite often you have to build a system around the kilowatt hours of a battery to get the power you need to run the inverter. So if you take an SP Pro SPMC 482, which is a 7.5 kilowatt inverter that can peak at 18 kilowatts, to get enough power out of a small battery just doesn't happen. You'll harm the battery, so you have to put a lot more kilowatt hours in to get that to work. Whereas these batteries here are such high peak power. This one here, packed in 24 cells in series, is a 40 kilowatt battery, and only weighs 43 kilograms. So your energy density per kilogram is extremely high, which means one battery can run one inverter. You only get 2.2 kilowatt hours of storage out of it, so that's probably not enough, but might be for some applications. And then you can just keep seriesing them. So we make them in different pack configurations, from 55 volts down to 6.9 volts. And then you can series connect and parallel connect, as long as you deal with your safety properly in your paralleling solution. And we developed a solution for that as well, which we call the bus duct. So we started producing that maybe about 4 months ago. And we basically parallel batteries together with touch-free connectors. And then we break it into another segment and fuse protect between the segments. So we end up with sort of a infinitely scalable bus duct.
Yes, because the fault currents get insanely big unless you've got segregation of your protection.
Yeah, so we had a really good engineer. His name's Jeremy. He did all the calculations around this and came up with an answer that said you can probably do 3 to 4 batteries in parallel before you start having problems. So let's call it a 4 connector bus duct. And then we bonded that to the next bus duct with a set of really high current fuses. And then the same touch-free connectors allow us to plug the inverter in. So you can take a 4-segment bay and put 3 batteries in one inverter, and then you can keep going along. So if you're doing a 3-phase system, you could have 12 batteries and 3 inverters, and just keep going out to more batteries and more inverters. It's sort of infinitely scalable in each direction.
Wow. Okay. So
it just makes it so much easier to design than it used to be. Like, you'd have to design this massive DC switchboard with huge isolators and rat trap fuses, and just kept it very simple. Which,
by the way, you can't use any more rat traps, everyone. Rat traps are IP20. They're going to be IP23 now. But,
yes,
but you can still use them as fuse holders as long as you don't call them an isolator.
Okay. Interesting.
Yep. Hey, just thinking of the small scale, I've got a story for you, which is we were mixing some concrete, or we were about to mix some concrete here for the EV charging station for the posts. And my builder said, "Oh, have you got a mixer around here?" I go, "Yeah." And I just get the concrete mixer out. And he goes, what are you going to power it with? And I just grabbed your 12-volt battery.
Oh, the one I gave you?
Yeah. So I had just one 12-volt battery, and he goes, "You're kidding me? That's going to run the concrete mixer?" And I go, "No worries."
And how long did it run for?
Oh, all day. I must admit, we've got a little cheat there. We have a DC motor on the concrete mixer.
Okay.
So it's got an E-Tech motor which can run from 0 to 48 volts, basically. Just goes faster as you turn the volts up. And yeah, we just ran it directly, like with a couple of bulldog clamps straight onto the battery.
Yep.
And, you know, the mechanism for turning it off was just to disconnect the bulldog clip.
Right, okay. That's actually interesting. We had another guy buy one of our batteries in a similar fashion. He had a client who moved into an off-grid house, which I think was occupied by 2 people with his family of 5. And there obviously wasn't enough power to run all of the iPods and whatever else, hair dryers. So he upgraded the inverter, and then the battery struggled. The lead-acid battery couldn't deliver the peak power needed for the new inverter to run the house. So he took one of our batteries and just paralleled it with the lead-acid battery. Worked a dream. So every time we had a massive load come on, the RVO battery would throw the energy into the inverter. The lead-acid battery would say, I can help a little bit. And then when the load went away, then they would just equalise out again. So he was pulling, I think, 300 amps through our battery at 55 volts, I think it was, which is, maybe it was 27 volts. Yeah, anyway, so it was pretty high. It's like about 8 kilowatts out of our battery, and then maybe 1 kilowatt out of a lead-acid battery. A similar application.
Yeah.
One battery saved the day.
We did that, remember, here at the lab, and it's a great way of using lithium to make lead go farther. I mean, effectively, old lead starts to get weak in terms of capacity and peak currents, and you just add in parallel a suitably voltage matched lithium system, and you've suddenly got the hero who comes and saves the day.
Yep. And also it gives new life to old lead, doesn't it?
Yeah. I think it's a way of extending a system. I mean, it's pretty hard to expand a lead acid system with lead acid because you've got old cells, you can't mix them with new cells, but the lithium battery doesn't really care. You just got to manage the voltage a little bit carefully.
And also, I think having a battery that can do tons of cycles helps with this too, because then it doesn't matter that the battery is doing 2 cycles effectively while it discharges and catches up again if it's a good cycling battery.
Hey, change of topic. So I know that we've been talking a lot about batteries, but you do other things in your business. So I hear the words Passivhaus thrown around a bit.
Ja, Sie müssen in Deutsch sprechen, wenn Sie Passivhaus sagen. It means you have to speak in German when you say Passivhaus. So Passivhaus is it's actually started in Austria, but it's spread throughout Germany mostly, and then throughout the world now. So Passivhaus is a European building method where you it's called building physics, where you look at the losses and the gains of a building, right from the insulation to the thermal bridges to the air changes per hour to the air tightness of a building and so on. There's a ton of different elements that come together, and the goal is to get 90% of your loads lost from your heating and cooling plant. So instead of having 100 watts per square metre of heating or cooling required for a building, you have 10 watts of heating or cooling required for a building.
Wow, that's a 10 times reduction.
10 times reduction, or you don't get a pass.
Or you don't get a pass.
No,
wow.
You don't get nothing. You don't get Passivhaus certified partly. You just get nothing. So you have to hit it, and you can model the building in advance through a tool called PHPP. So I became Passivhaus certified about maybe 4 or 5 years ago, and it just basically is a very complicated course that teaches you how to apply all these natural formulas and methods to get this outcome. So you've got orientation, you've got glazing, thermal bridging. One of the rules in Passivhaus is you can't let anywhere in the building fall below 13 degrees Celsius at any time through the year without using any heating.
Okay,
because at 12.5 degrees, mold can form.
That's fascinating.
So this is like, well, this stuff exists. This is how they build in Germany.
Yeah,
and I think it's in Austria. They all government buildings are Passivhaus certified. They must be built that way. That's the rule.
Right.
And the reason is the government owns them.
Yeah.
And you think about 90% heating and cooling bill reduction for 40 years, how much money that is for the government. It's enormous. So it's far more saving in energy than it costs in the upgrade of the building.
Yeah. I mean, it makes our building standards look stupid, and 5 stars plus. It's not even trying. It's slightly better than the tent.
Well, I did my diploma in building and construction about 3 years ago. Thought I'd just do this course. Took night school, I did it. So I learned a lot more about standards and commercial construction and so on. So I can become a commercial builder now if I wanted, but I'm not. But it helped a lot with all of what we do now. to understand those standards. And I think there was a 2-night session on environmental design in the whole course.
Yeah, right.
So I'm not surprised the builders aren't building better because the system doesn't tell them to.
Yeah.
It is changing though.
I mean,
It's
it really,
improving.
it does take policy to make those changes, because if you just say to someone, you know, your business is selling houses, you'll try to make them as cheap as possible to sell. You don't care about the running costs because that's someone else's problem. But if you put policy around it to say that you have to hit certain performance criteria for the benefit of everyone, which is the environment, the community, and the people who buy that house.
Well, that's right. And one of the things that they did mention in the course was that they're talking about bringing in air tightness tests on homes, and everyone's going, wow, that sounds like a great idea. And Passivhaus has been doing it for like 25 years in Germany. And so to do a Passivhaus air tightness test, they put this large sock on the front door with a fan built into it, plugged into a computer, and run the fan up to 50 kilopascals and pressurize the building and look at the loss of air pressure using a computer. And then you go around the building with a thermal camera and you can see all these cold points where the air's escaping through the building, because they do both way pressure test. And then they go, okay, why is it escaping? You do this before you plaster the walls. So all your building films and taping has to be done before you plaster, so you can go and fix any holes that you've not fixed, or the plumber might have put a hole through the membrane and not taped it up. And once you get that right, then when you go and plaster it up, it's even more airtight. And so you can't have more than 0.6 air changes per hour under pressure at 50 kilopascals.
Yeah, look,
Most houses get 10 to 30 air changes per hour at that pressure, and we're getting 0.6 at Passivhaus.
So I've got friends in Germany who I've stayed with many times, and they bought a 1950s, you know, basically just end of World War II concrete block house, horrible performance,
Yeah.
and because it was cheap. But then the German government started offering green loans. And, you know, we had green loans in Australia. I think they were like $10,000, and they're so hard to get that no one got them. In Germany, this they got €84,000 to improve the energy performance of their home, but the catch was it had to be tested. So at every step in the process of the house build,
Passivhaus is that's the rules.
that's right. And the blower door test, you know, all the thermal imaging. I mean, it was really rigorous, and they had to get the design signed off by an architect who was probably equivalent to Passivhaus certified.
They would be, yeah.
Before they'd get the bank loan. So, you know, you couldn't just take the money and go, oh, yeah, we'll put double glazing in. Good to go now.
Yeah.
You had to prove the performance benefits as part of that loan. And it was 1% interest rate. It was like, yeah. And so what they're trying to do is the most of the housing stock takes like 100 years to turn over.
Yeah.
So, you know, it's going to take 100 years to improve the performance by just replacing the building. You might as well improve what you've already got.
Accelerate it, yeah.
Yeah, yeah.
So that program's called Enofit. So within PHPP, there's PHPP is for a new build, and then Enofit is for an environmental upgrade.
Yep.
And you're allowed to get, I think, up to 2 air changes per hour under pressure with Enofit.
Wow.
They're more relaxed because you can't fix all the holes, obviously, in some buildings.
Yeah, yeah. Yeah, they did a complete wrap of this building, and, you know, even right down to the timber had to be sustainably certified, and what do you call it, stewardship certified, whatever.
FSC.
FSC, that's the word for it. Yeah, FSC. Yeah, so it's like uber green.
Yeah. Obergrün.
Ubergrün. Yeah. Cool. So what else does Avio do? I see you've got a couple of things here up on your website.
Yeah, well, we develop software, which is a big part of the energy system. So we have our own software coders, and we write. We developed a web page called myavio.com.au that's being used by about maybe 600 or 700 different clients at the moment to access their inverters and generators and all kinds of things. So we manage a fleet of microgas turbines. We've just recently deployed systems throughout Queensland in hospitals to manage generators and control them for energy arbitrage. And so the software platform is very flexible, that you can add any kind of controllable device to the internet and do things with energy. And that sort of plays into the whole idea of load shedding and battery storage. We are working on a few clever little projects at the moment where we're looking to connect to swimming pools to utilise that waste energy into swimming pool pumps to slow them down when there's spare energy and so on. So that might be a product we bring to market soon. Basically, the idea is how do we help save energy and do it sustainably. It has to be sustainably economically as well. You know, the product has to far outlast the energy payback, like the argument with the batteries before. The battery pays itself off by the time it's dead. Why did you do it? Might as well buy shares or Bitcoin or something. Tesla stocks, maybe. I don't know. So, make sure it's got a long payback that just keeps on paying back, and then you can argue that it's a very good investment for somebody. I think that also plays into the idea of environmental sustainability too, because if you look at a product, this is how I look at a product. A product is probably 1/3 energy, 1/3 labour, and 1/3 profit. That's what a product is. So the price of a product, you can actually work out how much carbon's embedded in a product by dividing the product by 3 and then dividing by the price of energy.
Oh, I see. Yep.
More or less.
Yep.
To get your head around it. Someone said to me, solar panels will never pay themselves off by the time they've expired their warranty. I'm so sure of it. I said, okay, let's just test the logic for a minute, right? So currently a solar panel is $150. So $50 must be the energy. $50 must be the labour, which is like winning the raw materials and building it. And $50 is profit. So $50 of energy divided by the cost of energy in a factory price might be 10 cents. That must be 500 kilowatt hours of energy. So the emissions from 500 kilowatt hours versus that panel, and you can work it out, and it's 1.5 years. So you can't even argue that solar panels don't pay themselves off just by doing a bit of logical math.
Oh wow, I really like that formula. I know that truth.
They're made up numbers, but you can see the principle.
But it's actually been modelled by a lot of academics, which is what is the embodied energy of a solar panel, and it's depending on how sunny it is, it's like 1 to 2 years mostly. Yeah. So you're right in the money there on that rule of thumb.
Same thing with batteries then.
Okay.
So you divide the cost of the battery by how many cycles it will do over its life. So with this cell here, it's 25,000 cycles.
Yep.
It's 92 watt hours and it has a price. So you can work out the actual embodied energy in that cell and how much energy it takes to make it and how much it can deliver over time. And that's why that's one of the reasons we chose a cell, because it worked out the most mathematically sensible cell to buy, as long as you can afford the capital price.
Yeah, but the difference with a battery and a solar panel is a battery doesn't generate renewables, it stores renewables.
Yeah, but it stores it multiple times. So I'm talking about the number of times you can store the energy you made from the solar panel.
Gotcha.
Maybe you couldn't store it, or maybe you weren't allowed to export it anymore because AMO changed rules, for example. Or PowerCore said to you, like they did to us in Armidale the other day, you can't have export on your solar power system for your client. I said, what? They said, no, the street's full. Yep. I said, really? That's interesting, because there's only 2 solar panel systems in that street. How did they get full all of a sudden? Let us review it, they said. And they came back and said, actually, no, you can. So,
hey, hot tip, everyone. Make sure you go and count the number of solar panels in the street before you get knocked back by your DNSP.
And never take no for an answer.
I think that's your motto in life.
That's right. Push and push and push until there's absolutely no, and that's okay. I'm all right with that. If it's a hard no and there's no way past, I'm okay. But
Hey, look, let's take a really big tangent here. So the other thing we have in common is we're both vegans.
Oh, yes. Right. I've been vegan since I was 28.
Wow.
And I'm about to turn 50.
Wow.
So it's 22 years now. So 22 years with no animal products, no milk, no egg, no honey, no meat, no fish, no chicken. Not like in my big fat Greek wedding. Hey, I'm vegetarian. That's okay. I got lamb, So no, and my children are the same. So we have 5 children from age 7 to 17, or 8 till 17, and none of them have ever had any animal product. They were born vegan, they were raised vegan, and they don't even have any idea what it is. They just see it on TV and go, why do people eat that stuff, Dad? And they're all very healthy.
So they're not all sort of flimsy, weak little pale creatures that can barely walk.
Can I show you a video?
Maybe we can drop it in, but
yeah? Okay, well, I'll show it to you later on.
Yeah.
But my daughter Jamie just won the state tumbling champion gold medal.
My God, really?
2 gold medals on the weekend, and now she's on the state team, and she's already won nationals in acrobatics and nationals in gymnastics, and she's 13.
Right.
And she did, I think, a round off back flip, 8 back salts, and a backflip twist to win the gold. Now she's 13.
They're going to have to ban vegans. It's an unfair advantage.
It is actually unfair. If you actually, there's a TV documentary about it. I'm not sure what it's called. I can't remember what it's called, but there's a really good one that goes into all these high level athletes that actually went vegan to win. they all went vegan because they found that was the most efficient food source for their sport. And then some of them stopped being vegan after they won all their medals because they wanted to go back and have McDonald's for some reason. And other ones kept on being vegan. So
Wow.
it's certainly a lot easier to have a lot more energy.
Yeah. I was kind of a bit late to the party. I was vegetarian basically for the last 30 years. But I guess when I think about it, I became vegetarian for emotional reasons, which is, I felt bad about eating animals. But I mean, I didn't take it far enough. I just kind of thought, well, I'm not actually eating the flesh of the animal, but then I started thinking, well, I'm still involved in that process, drinking milk and cheese. I'm still exploiting animals. So that was kind of my motivation, I suppose. But people come to veganism for lots of different reasons.
Yeah, I think my first reason was I read about it and it was so logical. You can't argue with it. Just when you look at the reasoning behind eating meat and dairy products and what it does when you have it and what it does when you don't have it, and you try not having it, you feel so good. You think, well, why didn't someone tell me this when I was younger? It's not very fair. So I felt ripped off. That I spent 28 years of my life not knowing this information. In fact, one of the biggest things I found, I've got white skin, like pale skin, and my parents tell me that's from my German heritage or my English heritage, and that's why I'm so sunburn sensitive. The government told me I was sunburn sensitive because the hole in the ozone layer opened up. They told me that was the reason. So I used to burn in 20 minutes in the sun, like 40 degrees. I'd have to put sun cream on every time. So when I became vegan, I thought I'd learned that fruit helps with your natural sun protection. So I thought I'll try this out. So I was in Queensland. I've been vegan for 4 weeks. Okay, so it's quite a quick transition. I thought I'll try it out in Queensland. So I was on the wharfs at Patrick Stevedores. We were installing a surveillance perimeter system for Patrick Stevedores when they were building a robot handling facility for moving containers around, and they couldn't let people in there because they'd get squashed. So we were out there installing this system so they could build this robot handling system. And I thought I'll try out this natural sun protection. I'd have a hat, I'd have sun cream, and I was like fully lathered up. But this time I'm going to try having no sun cream for the day. I worked outside with a t-shirt, 40 degrees in Queensland in summer for 9 hours, full sun, and I had a mango every hour. Came in with a light tan. I'd never had that before, ever. I was burned to a crisp boy, lobster boy, sunstroke in an hour. And here I was going, I don't sunburn anymore. Hang on a minute, something's happening here. So I kind of felt ripped off that I'd had dairy all this time. So I think there's a connection to dairy, but I don't know if there is. But in any case, lots of fruit protects you from the sun.
I know this too because a friend she was a medical student and she was a bit poor at the time at university, and they were offering guinea pig payments for doing testing for sun creams. And so she thought, I can get some money for putting some dobs on my skin and them sort of putting me under a UV light for a while and seeing which one was most effective. Okay. And so she rolled up for the testing, and then they said, you had to answer this questionnaire. And one of the questions was, are you vegan? And she sort of vaguely remembered that actually not eating meat meant that you didn't get burned so easily. So she didn't mark I'm vegan. So she lied to get into the test program, corrupted the test
to get the money.
And she got way less burns than anyone else.
Yeah, it's directly connected, and it's very dynamic. It's like one day to the next. So if you wake up in the morning and you have, like for me, I make sure my stomach's empty from the night before. I don't have a heavy meal in the evening. I'll have, this morning I had, I think, 8 figs for breakfast and some honeydew from my neighbour's tree, the figs. And then that would be enough to protect me for the whole day. I go out, I haven't worn sunscreen for 22 years. Don't even buy it. There's none in the house. The kids never wear it. They're all blonde haired, blue eyes. They've never had sunscreen on. Friends come over and say, "You've got sunscreen?" And the kids are going, "Do we have sunscreen, Dad?" I said, "Yeah, there's an emergency bottle in the other bathroom in the drawer. It's blue."
It's in the fruit bowl.
They go and get it. And they bring it out for their friend. And if that's a testimony to being vegan is very healthy, I think. It's a direct, visible test. And anyone who doubts it, it's a way you can test it.
I mean, I guess the other angle, which we probably share in common, is that the environmental benefits. I mean, if we were thinking about the sustainability of this planet, eating animals is the least sustainable way of feeding a population.
It's terrible. Like it's kind of funny, you see someone, I've got solar panels on my house, I'm going to help the environment. I'm going to buy an EV, I'm going to help the environment, and then they go and have a big steak dinner. So the statistic is that it can be verified by others, but the statistic is that 50% of carbon emissions worldwide come from animal husbandry. It's half. And if we didn't have animal husbandry, which means if nobody ate animal products or drank milk or ate eggs, then half the problem would disappear. And the cost for doing it to people individually is nothing. There's no cost. There's no investment cost. There's no solar panels. There's no buying a $100,000 Tesla. It's just not doing something. So half the problem is in everyone's hands to change, and they can change it in a day. I became vegan in one day. I used to hunt my own kangaroos. I used to catch my own fish, catch my own lobsters. Basically, my rule was if you can catch it, you can eat it. If they make it, you can eat it. That was my rule. And then I thought one day I developed a conscience about it after reading about it and stopped doing it. And I felt so much better. I felt much healthier. Like I lost weight. I felt better. I was happier. I slept better, and so on. I had more energy, more stamina. I used to do the Puffin Billy race every year, the 13-kilometre run against the train up the hill.
Yep.
And I would never train. I'd just turn up. I'd just fruit load. I'd have like a watermelon before the race, and I'd finish the race and I wasn't sweating. So there's a really good reason to go vegan, but the environmental benefit is enormous. I think transport is 10% of the problem. So if everyone bought an EV, we've solved 1/10 of the problem. If everyone goes vegan, you solve 50% of the problem. The EV costs $100,000. The vegan diet costs nothing. In fact, you save money. It's much cheaper. So yeah, definitely environmental, but also you feel better for doing it. So.
This might be a bit controversial, but we've had a lot of floods in Australia recently, particularly in New South Wales, and the TV's been, excuse the pun, flooded with pictures of animals stuck out in paddocks and farmers crying their animals are drowning and stuff. And it kind of feels hollow to me because they're actually growing those animals to kill them.
I know.
But they're feeling sad that they're getting wet feet.
I struggle with that too. When you see the RSPCA endorsing a particular brand of chicken or pork and saying it's sustainably made, killed, the pig still got taken off and shot with a bolt in the head and then chopped up for people to eat when they could have just eaten the corn that they fed the pig and felt much better for it and had much less environmental harm. I just don't get the whole idea of RSPCA endorsing safe animals.
I mean, if you say that you care for your animals, to substitute that with a family member.
Yeah.
So, and how would you treat them?
That's exactly right.
Yeah.
Do unto others as you have them do unto you. That's the old golden rule.
Yeah.
So,
yeah. I feel really bad about Granny being out in the paddock there with wet feet. But once we get her onto dry land, we'll just slaughter her and send her off to them. She'll have done a job.
It's a bit ironic,
Yeah.
But I think an easier argument for people than that one, because that's more controversial. I like my meat taste, is that you actually live longer. Like my children, I don't know that we've seen the doctor. I think that one child dislocated her shoulder when she was 8, and apart from that, 5 children, maybe 1 or 2 doctor's visits in 18 years. There's no burden on the Medicare system. Your children don't get sick easily. I don't know what would happen if coronavirus came across a vegan child, but I don't think very much would happen, to be my suspicion, because the immune system's so strong.
Yeah.
And you defend yourself against diseases very quickly. So there's a ton of side effects. You should read up on it, which you already have, but you guys should read up on it.
Yeah. Oh gosh, there's so much to say about this. So people sometimes criticize vegans for eating food that has a meat taste and, go, oh, look, if you like that sort of pseudo bacon, why don't you just eat bacon? And I go, well, actually, I didn't stop eating meat because of the taste. Because of the murder. There's a different motivation.
You can't murder a bean, can you?
That's right. Yeah. I mean, just because you people say, oh, but it tastes so good. How could you possibly not want to eat it? And I go, well, maybe your grandma tastes really good too, but you don't choose to eat her.
Well, that's one way to look at it. I mean, I often think about it too. Like people say, "Oh, but I love the taste," and you say, "Okay, so can you remember a taste?" You can remember an image, you can remember a sound, but you can't actually remember a taste. You can't. Your mind doesn't let you do it. The taste only lasts for that period of time while it goes from here to there, which is about 3 seconds.
Yep.
So you get 3 seconds of pleasure per mouthful times 30 mouthfuls. That's 90 seconds of pleasure. And then your body has to deal with this burden, which is actually very difficult to deal with compared to vegetables. And so you get 24 hours of pain for 90 seconds of pleasure. Not a very good equation.
No. You know, on a kind of a selfish note too, there's never been an easier time to be a vegan. Like, you know, when I became a vegetarian 30 years ago, that was pretty weird. And, you know, you go to restaurants and they'd say, "Oh, sorry, nothing vegetarian here." I mean, it was basically meat, and meat.
Yeah.
But, you know, now you just like have all vegan restaurants. It's kind of like, yeah.
I think there was a really good quote by one of the Beatles. He's vegan. I think it's Paul McCartney. And he said, you can tell a lot about a country by the way they treat their animals, which is, I think there's a lot to be said about Australia in that area. But when I went to World Vegan Day when I was 28, when I first became vegan, there was about maybe 200 hippies sitting around a campfire and grilling a veggie burger at Albert Park Lake. Okay, with 2 little stands saying "buy our soap" and "buy our veggie patty." That was about it. I went to World Vegan Day at Melbourne Showgrounds last year, and there would have been about 30,000 people. You could not get in the doors. It was crowded. There was like 500 food stalls and all these products and kids running around that had been bought from vegan families. And I thought, hey, things have changed.
I was there too. It would have been 2019, I think. I don't think they had.
Yeah, maybe it was. Yeah, it was.
Yeah. I was there too. You know, the weather wasn't that nice. I mean, it was being overcast.
It was packed, wasn't it?
But it was packed with people. Yeah. And like, you know, just amazing range of goods and food. Yeah. So it's totally mainstream.
But people think, "Oh, it must be hard being vegan," they say to me, and I keep saying, "Look, it's just normal. We are vegans." Like, you think about, there's a few reasons for this. This is my explanation, if you don't mind me going on about it. The first thing is the jaw. Okay, so carnivores have got locked jaws. Their jaw doesn't move left and right. It only goes up and down because they have to be able to catch the rabbit and tear it open and eat the rabbit. Okay, all the herbivores, their jaws go left and right because they have to grind. Look at our jaws. Oh, funny. Grinds. It doesn't go like that. It's not locked. We can't kill a rabbit with our fingernails and our teeth. Can we? No, but we can use tools. We're clever. Okay, fine. Good argument. Next thing is your intestinal tract. So the intestinal tract of carnivore is 4 times its torso length. So bears, tigers, whatever, you name it, an animal that's kind of similar to us, and it's a mammalian, for example. The length of the intestinal tract on a herbivore is 9 times the length of its torso, and a frugivore is 12 times the length. So a fruit-eating animal. And guess how long a human's is? 12 times.
12 times, yep.
So we're frugivores by intestine, we're herbivores by jaw. And if we don't eat animal products, we live perfectly well. Someone says, "Oh, but we're meat eaters." Well, no, we're not really not. We're just confused. Confused frugivores. So, and I think you live a lot longer. You feel younger and you feel better. So go vegan. Do it for yourself. And then the planet benefits and all the animals benefit. They'll thank you for it.
Hey, Paul, this has been great talking to you. Joy, I didn't know where we'd go with this podcast, but amazing territory from batteries to veganism. So there you go.
Yeah.
So, thanks for coming.
Sure. Thank you, Glenn.
And look, it's been great getting to know you over these years and all the exciting things that you have done. Yeah. And I look forward to hearing more on all those projects that RVO keeps running up.
Well, there's a lot more to come. So we've just had an investor step into the business to help develop and grow the company into much larger scale production.
Yep.
And that's literally being signed off now. So there'll be a lot more to come.
Great.
And we're looking to support all the system integrators and installers with our technology. And that's the development pathway has been a lot of self-installs for us to date and reselling cells and batteries and software to people. But that's going to develop a lot more in the future.
Cool. All right. Cheers.
Cheers.
Well, thank you, Paul. That was a great podcast. I never know where they're going to go sometimes. We just ramble and sip on some beverages and see where life takes us. So, yeah, it was great sharing those experiences about batteries, energy storage and veganism. Yeah, a bit of everything there. So thanks once again to everyone who's watched this series, and it has evolved somewhat. I'm doing a bit more of the podcast on my Toolbox Tech Talk, but don't you worry, I'll be back to some more just me and the tech, and maybe with some live guests. But, you know, life goes on. So the other thing is I'm running a crash course in the new battery standard coming up in a couple of weeks, the 21st and 22nd of April. And it really is aimed at people who have been working in the industry for a while, but are not across the new battery standard, AS NZS 5139. So if you want to really come up to speed with that standard and make sure that you're being compliant, please check out my training course. Go to solequip.com. Link will be in the description probably, and you can register for that. So it's on a Wednesday and Thursday evening, 4:30 till 8:30 Melbourne time, and it's also recorded. So if you can't make both sessions or either of them, you get to watch the recording as well. Anyway, till next time, see ya.